In last class I have completed part B questions, and in today's class I am going to solve part C questions. So look at the question number 25. Show that the relation R defined in the set A of all triangles where R is equal to T1, T2 such that T1 is similar to T2 is an equivalence relation. Here we need to prove that the given relation is an equivalence relation. Equivalence relation means what? If I want to say any relation, if it is an equivalence relation, it should satisfy the condition of reflexive, condition of symmetric, and condition of transitive. So let us prove one by one. Take first one, reflexive. Okay. As let me take triangle T1. As T1 is similar to T1 itself. Therefore R is reflexive. That is T1 is related to T1 only. T1 is related to T1 only. And second one, symmetric. As T1 is similar to T2, as T1 is similar to T2, which implies that T2 is also similar to T1. T2, second triangle, T2 is also similar to T1. Okay. If I take two triangles, say T1 and T2, if both are similar, if T1 is similar to T1, which implies that T2 is also similar to T1. That is what symmetric condition says, as in general A comma B belongs to R, which implies B comma A is also belongs to R. That is T1 comma T2 belongs to R, which implies T2 comma T1 is also belongs to R. Therefore R is symmetric. And last one, transitive. Here we need to take three triangles. Say if T1 comma T2 belongs to R and T2 comma T3 belongs to R. Okay, if T1 comma T2 belongs to R means T1 is similar to T2, and T2 comma T3 belongs to R means if T2 is similar to T3, so definitely which implies T1 comma T3 belongs to R. T1 comma T3 is also belongs to R. So therefore the given relation satisfied the condition of reflexive, symmetric, and transitive. Therefore the given relation R is an equivalence relation. See the next question, number 26. For the matrix A is equal to 1567. Verify that A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. Symmetric matrix means we need to prove that in general A dash is equal to A. For skew symmetric, if I take a single matrix, A dash must be equal to minus A. A dash is equal to what? Minus A. Okay, these are the conditions for symmetric and skew symmetric matrices. And here we need to prove that A plus A dash is a symmetric matrix. For that, find out A dash. Let A is equal to given matrix, it is 1, 5, 6, 7. and E dash is equal to transpose of this. It is 1, 5, 6, 7. Change the rows into columns or columns into rows. Now add these two matrices. A plus A dash is equal to, add the corresponding elements. 1 plus 1, which is 2, 5 plus 6, 11, 6 plus 5, 11, 7, 7, which is 14. This is what? A plus A dash. Now, A plus A dash, take the complement of above matrix. Sorry, transpose of this, which is again same. Okay, change the rows into columns or columns into row. Now 2, 11, 11, 14, 11, 14. This is what? A plus A dash of 4 dash. Okay, now compare these two matrices, they are same. Okay, that is A plus A dash of 4 dash is same as A plus A dash. That is A plus A dash is equal to A plus A dash of 4 dash is equal to what? Simply A plus A dash. A plus A dash. Therefore, the matrix A plus A dash. Therefore, A plus A dash is symmetric matrix. Is symmetric matrix. And take second one. A minus A dash. A minus A dash is pure symmetric matrix in the formula. For that, take the difference of these two. Okay. A minus A dash is equal to, take the difference directly. Again, take the difference of corresponding elements. 1 minus 1, which is 0. First element is 0. 5 minus 6 minus 1. 6 minus 5 plus 1. 7 minus 7 is 0. Now take the transpose of this. That is A minus A dash of 4 dash. Transpose of this will be what? Again, change the rows into columns or columns into row. So let me change first row. 0 minus 1. I will put first row in first column. 0 minus 1 and 1 0. So now in this matrix, take negative sign common. Okay. So it will be minus of. So anyway, you can write 0 as this. So plus 1 become minus 1 and minus 1 become plus 1 and this 0 as this. That is A minus A dash of 4 dash is equal to naught. So this negative sign as this. 0 minus 1 1 0. 0 minus 1 1 0. That is nothing but what? A minus A dash. A minus, replace this matrix by A minus A dash. A minus A dash. So that is nothing but what? A dash is equal to minus A. Therefore, A minus A dash is a skew symmetric matrix. Is a skew symmetric matrix. Look at the next question, number 27. This is from differentiation. And look at the equations. X is equal to 2 into t square and y is equal to a into t to the power of 4. So these two are parametric equations. Definitely you are going to get one question from parametric equations. And to find the derivative of this, we have to differentiate these two equations with respect to the parameter t only. So let us take the first parametric equation. Let x is equal to 2 into a t square. Differentiating both sides with respect to t. Derivative of x with respect to t is dx by dt. That is equal to 2a is a constant, write this as this, and derivative of t square with respect to t is simply 2t. Like derivative of x square with respect to x is 2x. And 2a into 2t is 4 times of a2. This is equation number 1. And similarly, take the second equation. Y is equal to a into t raised to 4. Again, once again, differentiating both sides with respect to t. Derivative of y with respect to t is dy by dt. That is equal to a is as this. A is a constant. And derivative of t to the power of 4 is 4 into t to the power of t. So that is equal to 4a into t raised to 3. This is number 2. Now, dy by dx is equal to dy by dt divided by dx by dt. That is equal to dy by dt value. So from the second equation it is 4atq, and similarly from the first equation we can replace dx by dt by 4a 4a cancel, and even 1t will be cancelled in numerator. So p square will be the final answer. See the next question, number 28. Find dy by dx if x to the power of y is equal to y to the power of x. Again, this is also from differentiability. Okay, from differentiation, you are going to get two questions. So one is fixed, which is from parametric equations, and another one may be from partial fractions or from logarithmic functions. If you look at the functions here, x to the power of y and y to the power of x, both are exponential functions. So ಈ ತರ ನಿಮಗೆ exponential functions ಕೊಟ್ಟಿದ್ದಾಗ compulsory log use ಮಾಡಬೇಕು. So now let us consider the given function. Let x to the power of y is equal to y to the power of x. On both the sides we are having exponential function. So that is why apply log. Okay, applying log on both the sides or taking log on both sides, very important. Without log we are unable to differentiate this function. Taking log on both the sides, log on both sides we get it. Now it is log of x to the power of y is equal to log of y to the power of x, and use logarithmic property. We know that log of m raised to n is equal to n into log n. Right? So therefore, log of x to the power of y means y into log x. This x into log y. So now we can differentiate this function easily. Okay, differentiating both sides with respect to x. Differentiating both the sides with respect to x. So look at the function on left hand side. This is the product of two functions. Y is also a function in x. So use product term. First function as this, take the derivative of second function. Log x is the standard function. Derivative of log x with respect to x is 1 by x. Plus keeping second function as this and taking the derivative of first function. Derivative of y with respect to x is dy by dx. That is equal to, again apply this same property, that is product rule on right hand side also. First function as this, take the derivative of second function. Derivative of log y with respect to x is 1 by y into dy by dx, because log y is a composite function when you are differentiating with respect to x, plus keeping second function as it is and taking the derivative of first function. Derivative of x with respect to x is 1. Now, so y into 1 by x is simply it is y by x plus log x into dy by dx, that is equal to again x into 1 x by y into dy by dx plus log y into 1 is log y. So now grouping the similar terms on one side, take this x by y into dy by dx to the left hand side, log x into dy by dx minus x by y into dy by dx, that is equal to log y as it is, log y minus, so take this y by x to the right hand side, become minus y by x. So taking dy by dx common here, dy by dx into log x minus x by y, that is equal to log y minus y by x. So take LCM here. LCM of 1 and x is x. So x into log 1. X log 1 minus 1 into y is 1. Same thing here also. So I can take LCM. It is 1. So y into log x. Y into log x. Now do the cross multiplication. Therefore, dy by dx is equal to, that is y into x log y minus y divided by x into this complete term, x into y into log x minus x. This is not the final answer. And the next question, number 29. Find the intervals in which the function f of x is equal to x square minus 4x plus 6 is strictly increasing. Okay, we need to find out the intervals for these two conditions, for strictly increasing and for strictly decreasing. And this is what the given function. And this question is from application of derivatives. So let us take the function. Let f of x is equal to x square minus 4x plus 6. Find its derivative. That is f dash of x is equal to a derivative of x square, which is 2x, and derivative of 4x is 4, derivative of 6 is 0. And now for increasing or decreasing functions, we have to take f dash of x is equal to 0. F dash of x is equal to 0 in the root. So what is f dash of x? It is 2x minus 4 is equal to 0. So 2x is equal to minus 4 become plus 4. So it is 2 times x is equal to 2. So now this single point divides the number line into two parts. So this is minus infinity and this is plus infinity. And this is 2. The intervals are minus infinity to 2 and 2 to infinity. Intervals sine of f dash of x and nature of f of x. Nature of f of x. Nature of f of x. So take first interval minus infinity to 2. Minus infinity to plus 2. So minus into plus, which is minus. Just multiply the sign of these two numbers. So minus and plus 2. Minus into plus, minus, negative. If f dash of x is negative, then f of x is strictly increasing. F of x is strictly increasing. Very simple. And take second interval 2 to plus infinity. 2 to infinity. So both are positive. Both the endpoints are positive. Plus into plus, their product is also positive only. So f dash of x is positive. Therefore, f of x is strictly decreasing. The negative one is decreasing. Strictly decreasing, and this is strictly increasing. Strictly increasing. So f dash of x positive one is strictly increasing. If it is negative, then it is strictly decreasing. See the next question, number 30. Evaluate integration of sin cube x plus cos cube x divided by sin square x into cos square x. Okay, this is from integrals. So this time you are going to get 3 questions from this topic. Question number 30, 31, 32. So look at the given integral. Let us take that as an I. Let I is equal to integration of sin cube x plus cos cube x whole divided by sin square x into cos square x. So let us use simplify the given expression first. Okay, it is unable to integrate the given function directly, so that is why do the simplification. Okay. Sin cube x divided by sin square x into cos square x we can write. Okay. Let us separating the terms. I is equal to integration of, it is sin cube x divided by sin square x into cos square x we can write, plus second term, that is cos cube x divided by sin square x into cos square x. And then I is equal to integration of I left with sin x in numerator, so sin by cos, which is tan x, tan x into, and 1 by cos, that is nothing but what, sec x, tan x into sec x. Okay, let me show this. Sin x by the remaining term in denominator is cos square x. So this can be written like this: sin x by cos x into 1 by cos x into variable. Again, cos x into cos x is cos square x, and 1 into sin x is sin x. So sin by cos is nothing but tan, and 1 by cos is nothing but what, sec. Similarly, for the second term also, cos by sin, cot x into 1 by sin, which is cosecant x, cosec x. Now I is equal to, it is integral of tan x into sec x, can also be written as sec x into tan x, plus apply the integral for these two terms separately into integration of cot x into cosecant x, can also be written as cosec x into cot x, and we know that derivative of tan x is what? Derivative of tan x. Okay, derivative of sec x is sec x into tan x. Derivative of sec x is sec x into tan x. Similarly, therefore we can replace this integration of sec x into tan x by, it is simply sec x. ನಿಮಗೆ ಡೆರಿವೇಟಿವ್ಸ್ ಅಥವಾ ಡೆರಿವೇಟಿವ್ಸ್ ಫಾರ್ಮುಲಾ ಕರೆಕ್ಟ್ ಆಗಿ ಗೊತ್ತಿದ್ರೆ ಇಲ್ಲಿ ಇಂಟಿಗ್ರೇಷನ್ ಅಲ್ಲಿ ಯೂಸ್ ಆಗ್ತದೆ. Derivative of sec x is sec x into tan x, exactly reverse. Integration of sec x into tan x ಅಂತಂದ್ರೆ secant x into variable. And similarly, derivative of cosecant x is minus cosec x into cot x. So integration of cosec x into cot x means minus cosec x plus c. So right, where c is a constant of integration. Indefinite integrals idaga constant add ಮಾಡಲೇಬೇಕು. See the next question, number 31. Find the integral of x minus 1 divided by x minus 3 divided by x minus 1 whole cube into e to the power of x. So take that integral as I. Let I is equal to integration of x minus 3 can also be written as minus 1 minus 2 divided by x minus 1 whole cube into e to the power of x into dx. Now I is equal to integration of I can separate x minus 1. Okay, then x minus 1 on kade group ಮಾಡಿ x minus 1 divided by x minus 1 whole cube minus 2 divided by x minus 1 whole cube. So ಈ ತರ ನಾನು ಗ್ರೂಪ್ ಮಾಡ್ಕೋಬಹುದು into e raised to x dx. Now here one term will be cancelled. I is equal to, it is integration of 1 divided by x minus 1 whole square minus 2 divided by x minus 1 whole cube e raised to x dx. Okay. And we know that, okay, it is of the form actually integration of f of x plus f dash of x into e to the power of x, and its derivative will be what? This is a standard formula. Its derivative will be it is e to the power of x into f of x plus c. So if you have the combination of f of x and f dash of x. F dash of x means what? Derivative of f of x into e to the power of x. So equal combination is equal to this is standard formula. So here 1 by, if I take 1 by x minus 1 whole square as f of x, definitely its derivative is what? Minus 2 divided by x minus 1 whole cube. Here where f of x is equal to what here? 1 divided by x minus 1 whole square, and f dash of x is equal to minus 2 divided by x minus 1 whole square. Therefore, I is equal to e to the power of x into f of x. This e to the power of x into f of x is nothing but what? 1 by x minus 1 whole square. 1 by x minus 1 whole square plus c, which is the required answer. See the next question, number 32. Evaluate integration of dx divided by x plus 1 into x plus 2. Okay, if you have the product of linear factors in denominator, then use partial fractions method. Okay, this is of type 1. If you have in general px plus q divided by x plus a into x plus b, then we can take that as a divided by x plus a plus b divided by x plus b. So let us make use of that first type. So this is from partial fractions. So let us take the integral. Let 1 divided by, so nothing is, I can take denominator as a 1 divided by x plus 1 into x plus 2, that is equal to a divided by first linear factor, that is x plus 1, plus b divided by second linear factor, b divided by x plus 2, and say this is equation number 1. Now take LCM on both the sides. It is 1 divided by x plus 1 into x plus 2, that is equal to LCM of two different linear factors will be their product. LCM of x plus 1 and x plus 2 will be, it is x plus 1 into x plus 2. Now do the cross multiplication. It will be a into x plus 2 plus b into x plus 1, b into x plus 1. Now on both the sides, we can eliminate the same terms even in denominator also. Become 1 is equal to a into x plus 2 plus b into x plus 1. Now say this as equation number 2. Okay. Solve for a and b. For that, use substitution method. If I take x value as a minus 2 plus 2 0, 0 into a is 0. So that I will get b value, right? Put x is equal to minus 2. X is equal to minus 2 in equation number 2 or in above equation. So simply 1 is equal to a into minus 2 plus 2, 0. 0 into a is 0. The first term becomes 0. Plus b into minus 2 plus 1. 1 is equal to minus 2 plus 1 is minus 1. Minus 1 into b is minus b, or b is equal to minus 1. Similarly, I got b value. So now we have to make second term as 0. For that, put x is equal to minus 1. X is equal to minus 1. Minus 1 plus 1, 0. 0 into b is 0. Put x is equal to minus 1 in equation number 2. Now equation 2 implies 1 is equal to a into minus 1 plus 2 plus 0. Second term is 0. And then 1 is equal to minus 1 plus 2 is plus 1. So simply it is a. Now put a and b values in equation number 1. 1 divided by x plus 1 into x plus 2, that is equal to a value 1 divided by x plus 1, b value is minus 1 divided by x plus 2. Now take integration on both the sides. It is integration of dx divided by x plus 1 into x plus 2 is equal to integration of dx divided by x plus 1 minus integration of dx divided by x plus 2. So this is I simply given integral. So integration of 1 by x is log x. Similarly, it is log of mod of x plus 1 minus log of mod of x plus 2, because integration of 1 by x is log x. Use Megavin property. So log m minus log n is nothing but this log of m by n, x plus 1 divided by x plus 2 plus c. C is a constant of integration.